What's up guys, Onmaths here, and today we're looking at number indices. So there are two different types of questions you might get, number indices and algebraic indices. They follow actually exactly the same rules, it's just the types of question you get with each will be slightly different. So first thing up, first exam board we're looking at is OCR. And there's some easy questions here and there's some nasty questions here. Ones I would expect my students to get right, ones I'd expect my students to struggle on. So the first one, square root of 121, you should just know your square numbers off by heart up until 15. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. If you don't know the square numbers up to 15, you need to sit down and learn them now. And you should know that 11 squared is 121, therefore the square root of 121 is 11. Okay, because 11 squared, or 11 times 11 is 121, it means the square root of 121 is just 11. Okay, and there's no trick of doing that, it just is you learning it, especially on the non-calculator paper, which this is on. Okay, next one I would expect students to struggle on because this is a rule, and the rule says that if you've got a negative power, you just put a 1 over it to get rid of the negative. So that is the same as 1 over 4 squared. Remember, the squared is still there, we just get rid of the negative. So 4 squared is 4 times 4, which is 16. So this is equal to 1 over 16. So the rule here is if you've got a negative there, so you've got a negative there, just put a 1 over it. And that's just, again, something you just need to learn. Okay, question B is a kind of BIDMAS or BODMAS question. We've got to figure out what order to do things in. So BIDMAS or BODMAS tells us what we've got to do. So the first thing we've got to do is the brackets. So we're only looking inside the brackets now. So we're only looking at this bit here, because BIDMAS tells us we've got to deal with that first. But are we going to do 9 take away 3 or 3 times 2? Well, multiplication comes before subtraction. Okay, so what we're going to do is we're going to do the 3 times 2 first, all following BIDMAS. So we've got 9 minus 3 times 2, which is 6 squared. Then we're going to do the subtraction because it's still inside brackets. 9 take away 6 is 3. And we can get rid of the brackets now that there's only the 3 in there. And 3 squared equals 3 times 3, which equals 9. So the answer to that's 9. Again, last question. 5 to the power of something equals 125. So we could try different ones. So I can try 2, so 5 squared. Well, that's 25, so that doesn't quite get us there. What about 3? 5 times 5 is 25. 25 times 5 is 125. So the answer to that is 3. And again, you need to know your cube numbers from 1 to 5 and 10. So you need to know 1, 8, 27, 64, 125, and then 10 cubed, which is 1,000. Next up is, I think it's Edexcel, yeah, it is. And this question relies on you knowing the rules, and the rules are that if you times with indices or powers, you add the indices. Okay, so you add the small numbers. If you divide, you take away. And you need to know those two rules. So I'm going to write this question out again because it's a little bit small on the screen. Oh. Okay, so we're going to deal with that top bit first. And here we've got to deal with the top first because we want one number divided by another number rather than two numbers divided by one and just get confusing. So instead of 3 to the power of 7 times 3 to the power of minus 2, the rule says I add them together. So it's 7 plus minus 2 over 3 cubed. Now, what wins between a plus and a minus? Well, the minus does. So we get rid of that. And that's just going to be a minus. So it's 7 take away 2. So it's 3 to the power of 7 take away 2, which is 5. That's a dodgy looking 5. Okay, over 3 to the power of 3. And remember what I said, if you times and you add the powers, if you divide you take them away. So that's the same as writing 3 to the power of 5 take away 3, which equals 3 to the power of 2, which equals 3 squared. 3 squared is 9. Today's AQA question is a bit of a weird one. It's like question 29 on the paper, and it's non-calculator. All of today's questions have been non-calculator, but it's one of those ones that looks really, really difficult, but is very, very easy. And for a question 29 for 2 marks, this is like a dream come true. And I'm going to write a different question, and then you can kind of see what this question's on about. Okay, so if I write a really complicated number, I'm going to be original here. Okay. Right, and already you're thinking this calculation is going to be complicated. I want you to do it in your head. Okay, I want you to times it by 82.3 and then divide it by 82.3, right? You'd think, oh, actually that's quite easy, because if we times it by a number, right? If we times any number by a number and then straight away we divide it by that number, I probably should put brackets in here, really, but anyway. If we times it by a number and then divide it by the same number, we just end up with the same number, right? So the answer to that would be, let's pick a more visible colour. The answer to that would be the same number we started with. And it's called inverse operations. Basically, inverse means the opposite. So when we do something, then we do the complete opposite, we end up having done nothing at all. And that's exactly what's happening in this question. Have a look at that 3 here. We're square rooting it, and then we're squaring it. Well, square root and square are the complete opposite. They're inverse operations. They're complete opposite of each other. So we only end up with 3. Similarly, with the 2 there, we're square rooting it and then squaring it. So we essentially have done nothing. We've just undone it. Okay, so we're left with a 2. So the actual question is 3 times 2. Question 29 on the AQA paper was asking you to do 3 times 2. And I can imagine, I don't know the statistics on this, but I can imagine there was an awful lot of students who didn't get that question right, because it looks complicated. As long as you remember that square root is the opposite of square, and there's a lot of inverses, so I've shown you times is the opposite of divide, plus is the inverse of subtract, and there's other ones. If you do trigonometry, you have sine, cos and tan, and you have inverse sine, inverse cos, inverse tan. They're complete opposites of each other. Okay, so this question is actually very, very easy. However, I can imagine some students didn't realise the trick with this question and tried to sit down and work it out. I think it would have been easier with this question, and this is probably why they didn't do it. If they'd done 3 squared and then square rooted it times 2 squared, then square rooted it, it would allow you to do 3 squared, which is 9, square root it, which is 3, 2 squared, which is 4, square root that is 2, 3 times 2 is 6. But they've deliberately done it the other way around, just to test whether you really understand what a square root is and what a squared is. So I like this question. It's sneaky, and it's definitely what we call an AO3 question, which is a problem-solving question. And generally speaking, those are the questions you should definitely want to focus on getting right in the exam, because more and more through the years, they've ramped up the marks, ramped up the percentages of those questions on the exam, because they really want to test whether you understand the maths or are just following an algorithm that your teachers taught you. Anywho, I hope this video has been useful and helpful to you. If it has, click like, it really helps. If you want to see more from us, we release videos Monday, Tuesday, Wednesday, Thursday and Friday. So click subscribe and make sure you're up to date. And you can check out our website, onmaths.com, with loads and loads of free resources for you to try out. And I'm sure there's a card that's hovering above us as we speak. Otherwise, thank you very much, and I'll see you tomorrow.